Alright, so we're going to start learning about polynomials, which is basically a bunch of terms put together with plus signs and middle signs in between them. Poly means middle, okay? Or mini, not middle. I'm dumb today. So the first thing we're going to do is we're going to find the degree of a monomial. Monomial degrees. Now a monomial is one term, so you're not going to be like looking at combining anything like that. So an example of a monomial is negative 2a squared b to the fourth. And how you find the degree of the monomial is you add exponents of variables to get degree. So if we're looking at negative 2a squared b to the fourth, we're going to do 2 plus 4, and that gets us 6. So it's a sixth degree monomial. The next one is just 4. Well, since you add the exponents of the variables to get the degree, and there's no variable, there is no degree, so it's just 0. The next one is 8y. Now remember, if there is no exponent by your variable, you can assume it's 1. You don't have another exponent to add the 1 to, so this is just a first degree monomial. Oops, that should say degree. Okay, the next thing we're going to do is we're going to be doing polynomial degrees. So that is when you're given a string of terms. Polynomial degrees. And the way you do that is you look at each term, and the term with the biggest degree wins. So we have 4x minus 18x to the fifth. Now 4x, you can assume that exponent is 1. You have nothing to combine it with, so that's not a negative 4x either, that's just a 4x. So let's not get confused about that. So this has a degree of 1. Negative 18x to the fifth, you have nothing to combine the 5 with, that has a degree of 5. Since 5 is bigger, this is a fifth degree. So you're not combining anything, nothing like that. You're looking at the first term, then you're looking at the second term, you're coming up with how many degrees are in each term, and then the biggest one wins. So the next one we got 0.5 x squared y plus 0.25 xy plus 0.75. So we're going to look at this term first. X has an exponent of 2, y has an exponent of 1, so we add those and we get 3. On the second term, x has an exponent of 1, y has an exponent of 1, we add those together and we get 2. And on the third term, there are no variables, so it's a 0 degree polynomial. So, since 3 is the biggest degree, this is a third degree. The next one they got for us, 6x to the fourth plus 9x to the second minus x plus 3. We're going to do the same thing. We're going to go through. First term is just a 4. nothing to combine. Second term, just an exponent of 2 with nothing to combine. Third term, there is no exponent, so we assume it's a 1. And the last term has no variable, so it's a 0. So the greatest exponent, because we didn't have to add anything, was 4, so this is a 4th degree polynomial. Now we're going to look at writing polynomials in standard form. In standard form. Okay, what that means is they want you to write your polynomial from the term with the greatest degree to the term with the least degree. So they're going to give you something like this: 20x minus 4x cubed plus 2 minus x squared. So you're going to go through and you're going to say, oh, 20x, that has a degree of 1. 4x cubed has a degree of 3. 2, there's no variables, so it's a degree of 0. And x squared has a degree of 2. So you want to write these from greatest to least. So greatest would be negative 4x cubed minus x squared plus 20x plus 2. Because then if you look at your degrees, you have 3, 2, 1, 0. So they're written in order from greatest to least. The next one, we have y cubed plus y to the 5th plus 4y. So we go through. This has a 3rd degree, a 5th degree, and a 1st degree. So greatest to least on the degrees, we would have y to the 5th plus y to the 3rd plus 4y. And that would be in standard form. Now if you can't read that, that is on page 407. But this is 2 tables. And some polynomials have special names based on their degree and the number of terms. So this first one is the degree and the special names, and the second one is the terms and the special names. And you need to know those because they will have you classify polynomials, which is what we're going to do next. We're going to classify polynomials, and when you classify a polynomial, they want it classified based on the degree and the number of terms. So if you're looking at a polynomial such as 5x minus 6, well, this has a degree of 1, this has a degree of 0, so it's a 1st degree. And it has 1, 2 terms. So then if you look up at that table, a 1st degree is linear, and 2 terms is a binomial. And we got that from here and here on those. So if they give you another one, my screen is not working, so that's cool. There we go. And they say it is y squared plus y plus 4. You have a 2nd degree, a 1st degree, and a 0 degree. So your term, or your degree is 2nd, and you have 3 terms, because you have 3 degrees down there that you've looked at. A 2nd degree is quadratic, and 3 terms is a trinomial. And then we have one more. We have 6x to the 7th plus 9x squared minus x plus 3. So we have 7, 2, 1, and 0. So it's a 7th degree. And we have 4 terms. Anytime you get a degree that's over 5, if you look up here on this section, you just stick with the number 7th and add degree to it. There's no special name once you get past 5. It's just the number of the degree. And 4 terms, 4 or more terms is always going to be a polynomial. There are only special names for 1 term, 2 term, and 3 terms. Once you get to 4 terms, it's just a polynomial. There's no more special stuff. I think that one's easy to read, but if not, it's on page 408. A firework is launched from a platform 6 feet above the ground at a speed of 200 feet per second. The firework has a 5-second fuse. The height of the firework in feet is given by the polynomial negative 16t squared plus 200t plus 6, where t is the time in seconds. How high will the firework be when it explodes? Well, they give you the equation, or the expression in the problem that you're going to use. You're going to use negative 16t squared plus 200t plus 6. It also tells you that the firework has a 5-second fuse. That means after 5 seconds, the firework is going to go off. And that t is the time in seconds. So wherever we see a t in our expression, we're going to substitute 5 for. So we have negative 16 times 5 squared plus 200 times 5 plus 6. We know that 5 squared is 25. We know that 200 times 5 is 1,000. Plus 6. We know that negative 16 times 25 is negative 400. And then we just plus 1,000 plus 6. And then we know negative 400 plus 1,000 is 600. And 600 plus 6 is 606. So it will be 606 feet above the ground when the firework goes off.